Okay, Mr. Rudra. So the topic that we are doing is Pythagoras theorem. Now Pythagoras theorem is simple, that perpendicular square plus base square is equal to hypotenuse square. So this topic is, the theorem is pretty simple. We'll be solving questions about it, and when we are solving the questions, there are few properties of geometry, basic geometry, that we will require. The first property that we will require is equilateral triangle. Mr. Rudra, what is the equilateral triangle?
So all sides are equal.
All sides are equal, so all the sides will be equal and all the angles will be 60 degree. Is there any doubt?
No, sir.
So this is 60 degree, this is 60 degree. Now I have drawn, this is a perpendicular bisector. What is a perpendicular bisector? Perpendicular bisector is a line which is perpendicular as well as it bisects the other line. Any doubt?
No, sir.
So if I consider triangle ADB, if I consider triangle ADB and triangle ADC, then this is 90 degree, this is 30 degree, this is 60 degree, 90, 30, 60, and this is a common side. So this triangle would be congruent to this triangle. Any doubt?
No, sir.
Okay. So if what you need to consider is that for an equilateral triangle, the perpendicular bisector divides the equilateral triangle in two equal halves. Any doubt?
No, sir.
Because these are two equal triangles. Let me state it over here. Triangle ABD is congruent to triangle ADC. So this side BD would be equal to DC. So this side would be x by 2 and this would be x by 2 if I consider each side of the equilateral triangle to be equal to x. Any doubt?
No, sir.
Okay, now this is x by 2. By using Pythagoras in this triangle, let us say triangle ABD, I will have the value of AD. The value of AD would be AB square minus BD square under root. Any doubt?
No, sir.
Let me write it here. AD would be a root of AB square minus BD square. And then all I need to do is put the values of AB and BD, and this is the value of AD that I will get. Any doubt?
No, sir.
Mr. Rudra, when we will be solving the questions, these are the results that we won't spend much time on, because that is why we are discussing all these results in the beginning itself. The second property that we need to understand is the second type of triangle that will be meeting would be isosceles triangle. What are isosceles triangle, Mr. Rudra?
It has two same angles and two sides are same equal.
Shabash, shabash. So let me state that AB is equal to AC. Therefore, this is an isosceles triangle. This side is equal to this side. This angle is equal to this angle. Now, if I draw a perpendicular from A to BC and I try to study the properties, now this side is equal to this side. This is a 90 degree angle. This is a common side. So can I apply right angle hypotenuse side, Mr. Rudra?
Yes, sir.
So if I apply RHS, then this triangle, that is triangle, 1 second, I'll delete this. So triangle ABD would be congruent to triangle ADC. Any doubt?
No, sir.
Okay. So these two would be congruent triangles, and therefore this side would be equal to this side. Any doubt?
No, sir.
Now let us come to the third figure. The third figure is a rectangle. In a rectangle, you need to understand that the two diagonals, of course, one of the given property which I am not stating is that all angles would be 90 degree, and another property of a rectangle that I need to remember is that the diagonals are equal. That means that AC would be equal to BD. Any doubt?
No, sir.
This is the property of diagonal that I'll be using when I'm solving the questions. And this is a rhombus. So we'll do a question which will have a rhombus figure also. For rhombus, you need to understand that all the sides are equal. All the sides are equal. That is the first property that you need to remember. And the second property that you need to remember is that AC and BD, the two diagonals of a rhombus, they are perpendicular bisectors of each other. Mr. Rudra, any doubt?
No, sir.
This implies that the two diagonals of a rhombus will bisect each other and they will be at 90-degree angle to each other. So again, this is a property that I would be using again and again while solving the questions. Any doubt?
No, sir.
AO would be equal to OC and OB is equal to OD. So what I'm trying to tell you is that when we are solving the questions, whenever we see a rectangle, we'll be using these properties. Whenever we are seeing a rhombus, we'll be using these properties. Whenever we see an equilateral triangle, these property would be used, and whenever an isosceles triangle comes, this property would be used. Any doubt till here?
No, sir.
Great, sir. So let us have a look at the first question that we have. Mr. Rudra, how will we solve this question? Okay, so Mr. Rudra, in this question, AD is perpendicular to BC. This is what is given to us, CABAX. Now, one thing that you need to understand is that all these are the lengths of the side. Is there any doubt about this?
No, sir.
Okay. Now, what you can do is, I have done the solution and I will explain the solution to you. This is what you need to prove. This is what you need to prove. Now, what I do is, I consider the value of C. The value of C would be h square plus a minus x square. Any doubt about this?
No, sir.
By Pythagoras. Again, the value of B would be x square plus x square. Any doubt about this?
No, sir.
Okay. Now what I do is, I have the value of C, I have the value of B. This is what I have found. This is what I have found. Now, if I look closely at equation number 1 and equation number 2, now what I have done is, I have put the value of C and B in what I need to prove. Mr. Rudra, any doubt?
No, sir.
So, have a look at what I have done and please ask if there is any doubt. So, Mr. Rudra, what I have done is, this value of C square and B square, I have put it here. C square and B square. So C square is equal to h square plus a minus x whole square. This is what I have placed here. Then a square is as such here. The value of B square is x square plus x square. And minus 2ax is as it is. Any doubt?
No, sir.
Okay. So when I open a minus x whole square, this is equal to a square plus x square minus 2ax. H square plus x square is h square plus x square minus 2ax and a square. And when I compare the left hand side and the right hand side, it is pretty obvious that all these will cancel each other. Therefore, left hand side is equal to right hand side. Any doubt?
No, sir.
Okay. So Rudra, in the second question, you are given an equilateral triangle. So equilateral triangle ABC. So we draw equilateral triangle ABC. ABC. Then AD is perpendicular to BC, and BC, this whole of this is x centimeter. Find x. Find in terms of x the length of AD. So I need to find AD in terms of x. Any doubt about the question, Mr. Rudra?
No, sir.
Have you understood the question?
Yes.
So see, if this is x, then this would be AB would be equal to So AB would be equal to X and AC would be equal to X. Any doubt, Mr. Rudra?
No, sir.
Now, as we have discussed, BD would be equal to X by 2 and DC would be equal to X by 2. Any doubt?
No, sir.
And if I have to find the value of AD, I will be applying Pythagoras theorem. AB square is equal to BD square plus AD square. AB square is X square. BD square is X square by 4 plus AD square. So therefore value of AD square would be, so value of AD would be equal to, if we solve, root 3 by 2x. Any doubt?
No, sir.
So if you want to see it clearly, and that is why we studied the properties of equilateral triangle, so that we can, when we are trying to do the questions, we don't face any difficulty. So this triangle is congruent to this triangle, and this is what has been mentioned. Therefore, this would be x by 2 and this would be x by 2. This triangle and this triangle are congruent, and therefore the value of AD, this value of AD would be equal to root 3 by 2. This can also be written as AD can be written as root 3 by 2x. Any doubt, Mr. Rudra?
No, sir.
Great, sir. In question number 3, Mr. Rudra, ABC is a triangle right angled at B. So always make a rough diagram. Always make a rough diagram before you start the question. ABC is a right angled triangle. Always take care where exactly is it right angled. It's right angled at B. M is a point on BC. Now M is a point on BC. It is not a midpoint. It is just a point. So I take any random point M on the side BC. Prove that AM square. So if they write AM square, I need to join AM together. Mr. Rudra, any doubt?
No, sir.
So AM square plus BC square. So I need to take this side AM square plus BC square. I need to take BC square also. So this square plus this square, I need to prove it to be equal to AC square and plus BM square. Mr. Rudra, have you understood the question?
No, sir.
Have you understood the question?
Yes.
Okay, so let's try to do it. So in this question, this is what we need to prove, that AM square plus BC square is equal to AC square plus BM square. So what I do is AM square plus BC square, I take the left hand side, take left hand side of what I need to prove. So AM square can be written as AB square plus BM square. This is what I have written here, and BC square I have written as it is. Now, when I look at these three and I look closely at AB square plus BC square, this square, this square plus whole of this square, I will get AC square. Any doubt?
No, sir.
AC square plus BM square as it is. AC square, whole of this AC square plus BM square. This is what is required, and this is equal to RHS. Cancelled. Any doubt?
No, sir.
It's Let's look at question number 4. M and N are midpoints. So they have given to be midpoints of the sides QR. So this would be M. And this is a midpoint. So this side would be equal to this side. And N are midpoints of QR and PQ. So this would be another midpoint. And this midpoint is equal to N. And therefore, this and this would be equal. Any doubt, Mr. Rudra?
No, sir.
They have also mentioned that this is a right angle triangle at Q. So this is the right triangle. Now I need to prove that PM square. This is the PM square. So I need to join PM square plus RN square. This is the RN square. So these two lines have to be joined. RN square. This should be equal to 5 times MN square. So this and this line also needs to be met. Any doubt?
No, sir.
So this is what I need to prove in part 1. Okay, let us look at the other parts also. So in part 2, 4pm square, 4pm square. So this is the pm line. This should be equal to 4pq square plus qr square, qr square. Now, how do we prove this? Now, let us look closely at the solution that we have. This is what I need to prove. This is what I need to prove. So pm square plus rn square plus rn square. This line square plus this line square should be equal to 5 times mn square. Now look closely at what I've done. I've written pm square as pq square plus qm square. Any doubt?
No, sir.
Now pq square, I understand, pq square would be equal to twice of q1 square. Any doubt?
No, sir.
Because this line is half of this line. So I have mentioned pq square as twice of q1 square, and when I open twice of q1 square, it is equal to 4q1 square. Any doubt?
No, sir.
Similarly, I consider rn square. I do not touch q1 square. Similarly, I consider this second term rn square. Rn square is this straight line. This is the Rn square. Rn square can be written as nq square plus qr square, and this time I'll reduce qr square, whole of qr square, as twice of qm square. This is the qm square, and this will be equal to 4qm square. And in the next line, pq square is equal to 4qm square. Qm square is as it is, nq square is as it is, and qr square is 4 times qm square. So, is there any doubt?
No, sir.
So these questions require a little bit of practice, otherwise you won't be able to understand. So 4qn square plus qn square is 5qn square, and qm square plus 4 times qm square is equal to 5qm square. Any doubt?
No, sir.
Now if I take 5 common out, I am left with 5 times q1 square plus qm square. And if I look closely at these q1 square and qm square, what I will get, Mr. Rubin? I will get mn square. Any doubt?
No, sir.
This is equal to 5 times mn square. So in the next part, Mr. Rudra, I need to prove that 4pm square, this is the pm square, 4pm square is equal to 4pq square plus qr square. Now pm square can be written as pq square plus qm square. I've taken the LHS. Then 4pq square plus 4qm square. Now, whenever you are doing such a type of questions, you should always be looking at the right hand side so that you are aware what you are trying to prove. Now, when you reach this step, Mr. Rudra, you should understand that 4pq square, 4pq square, 4pq square. So you need not do anything to this 4pq square. Just focus on 4qm square. And when you look at 4qm square, this is qm. So 4qm would be twice of qr, because qm is twice of qr. Any doubt?
No, sir.
Mr. Rudra, why is qm twice of, why is qm, why is, why qm is half of qr? Sorry.
Because M is the midpoint of QR.
Yes, sir, because it is given. So qm is half of QR. So when I write 4QM square, this I can write as twice QM square. So twice of QM would be QR, and that is what is written here. So this part is proved. Any doubt?
No, sir.
When I look at the third part of this question, the third part is 4Rn square is equal to PQ square plus 4QR square. Again, when you are trying to do this question, just have a look at what Rn square looks like. This is the Rn square line. Now this Rn square, whole of this Rn square by Pythagoras, I can write this as NQ square plus QR square. Any doubt?
No, sir.
Now 4 gets multiplied by NQ square, it gets multiplied by QR square, and the value that I get is 4NQ square plus 4QR square. Again, when I look at the right hand side of what I need to prove, I will see that 4QR square and 4QR square is common. So this is the only thing that I need, and that will come from here. And how it will come from here? That 4NQ square can be written as twice of NQ square plus 4QR square, and twice of NQ is PQ. So this will be PQ square plus 4 times QR square. Mr. Rudra, any doubt?
No, sir.
Then this is what I have done here. Second, third part. The fourth part is simple. Because from the first part and the second part, I can add the first part, 4PM square plus 4RN square. This would be equal to 4PQ square plus QR square plus PQ square plus 4QR square, and this will be equal to 5 times PQ square plus QR square. And what is PQ square plus QR square? That is equal to PR square. If I look at the figure, PQ square plus QR square is equal to PR square. Any doubt, Mr. Rubin?
No, sir.
So these questions are a bit complex questions. Maybe you'll have to do them twice or thrice so as to understand the question. Okay. So this is one of the difficult questions in this exercise. Question number 4. Mr. Rudra, have a look at question number 5, 6, and 7. Question number 5, 6, and 7. And you need to note down few things. This is a rectangle, so we need to use the properties of rectangle. This is a quadrilateral, no properties are available. This is a simple triangle. So do not try to use this as an equilateral or an isosceles triangle. Try to do question number 5, 6, 7. So Mr. Rudra, in question number 5, in a triangle ABC, let us try to understand the question. In triangle ABC, angle B is equal to 90 degree and D is the midpoint of BC. Prove that AC square is equal to AD square plus 3CD square. Okay, let us try to understand how we will do this question. So in this question, angle B is 90 degree. Any doubt?
No, sir.
D is the midpoint. So if D is the midpoint, BD would be equal to DC. Any doubt?
No, sir.
Okay. So what I need to prove is that AC square, this AC square, this is equal to AD square, this AD square plus 3 times CD square. So in our final, if we start from LHS, if we start from left hand side, so AC square would be equal to AB square plus BC square. Any doubt?
No, sir.
Okay. Now, whenever you are doing these questions, as I have told you before, just keep an eye on the right hand side also. So once I have written AB square and I've written BC square, I know that BC square I can write as DC square. Why? Because finally I'll require DC square here. Any doubt?
No, sir.
So BC is twice of DC. And that is why BC square can be written as 4 times DC square. I haven't done anything to AB square. Any doubt?
No, sir.
Then I break 4D square as DC square plus 3DC square. Any doubt?
No, sir.
Then when I look at AB square and DC square, AB square and DC square. So DC square is equal to BD square. Why? Because DC is equal to BD. Any doubt?
No, sir.
So AB square as it is, DC square I have written as BD square, and 3DC square is here. Now I won't be doing anything to 3DC square because 3DC square is part of my final solution also. And that is what I see here, that once I write DC square as a BD square, then AB square plus BD square, AB square plus BD square is equal to AD square. And this is my right hand side. Any doubt, Mr. Rudra?
No, sir.
So these questions, they require practice. You may have to do these questions twice or thrice. And another thing that these questions require is whenever you are doing these questions, just try to see what needs to be proved. Just keep an eye on the right hand side. You can also take the right hand side and then try to prove that right hand side is equal to left hand side. That also you can do. But whatever side you take, just keep an eye on the other side also. Question number 6. In a rectangle ABCD. Now this is a rectangle. This is a rectangle. Prove that. So if this is a rectangle ABCD, AC square plus BD square. These are the two diagonals of the rectangle, and I need to prove that these are equal to this. Now, as we have discussed before, properties of rectangle should be very clear. The diagonals are equal, they bisect each other. So these properties should be very clear. Only then you'll be able to do the questions. If there is any doubt, till here.
No, sir.
Let us look at the solution of this question. Okay. So I take the left hand side, that AC square plus BD square. AC square plus BD square. This is my AC. This square would be equal to AB square plus BC square. This square plus this square. BD square can be written as this square plus this square. This is what I have written here. Then AB square and BC square are the same. DC square is the same, and BC square would be equal to AD square. Any doubt?
No, sir.
Now, if you look closely at this, A, B, BC, DC, and AD, if you look at this statement, then what this statement is saying you is that sum of square of diagonals of a rectangle is equal to sum of square of sides of a rectangle. Mr. Rudra, any doubt?
No, sir.
So this question can easily be put in the form of a word problem. Any doubt?
No, sir.
So this is one of the simple questions which are there in this exercise. Let us move to the next question. In a quadrilateral ABCD, angle B is 90 degree and angle D is 90 degree. Okay, there are two angles which are 90 degree, and you need to prove this. Okay, let us look at the solution. Okay. So This is the quadrilateral that I have, A, B, C, D. I have been given that this is a rectangle and this is a rectangle. Any doubt?
No, sir.
I need to prove this. Now, what do I do? I first, what I need to understand is that it is not necessary that I should be starting from here. I can modify this statement as prove twice of AC square. I can take this side and I can modify the proof as twice of AC square is equal to AB square plus BC square plus CD square plus DA square. Any doubt?
No, sir.
Okay. Then twice of AC square. When I see twice of AC square, the first thing that should come in my mind is that I can break this AC square in AC square plus AC square. Why? Because this AC square I can write as AB square plus BC square, and this side of the AC square I can write it as AD square plus DC square. Any doubt?
No, sir.
And finally, this is what I wanted to prove. Now again, this can be written as that that twice of twice of square of diagonal is equal to sum of the square of the sides of a quadrilateral. Mr. Rudra, any doubt?
No, sir.
Question number 8. O is any point inside a rectangle. So O is any point inside a rectangle ABCD. Now what we need to understand is that we will make a mistake if we do the question like this. So Rudra, why will this be a mistake?
So because this will show that O is the midpoint of BD.
Yes, sir. They have mentioned that O is any point inside a rectangle. So you can't make any assumption of yours. So that we should be clear. Okay, let us try to do this question. Okay, in the next question, Mr. Rudra, the following figure QPOQOR are drawn perpendicular to the sides BC, CA, AB of triangle ABC. Now prove that AR square, this square plus BP square, this square plus CQ square, this square is equal to AQ square plus CP square plus BR square. Mr. Rudra, have you understood the question?
Yes, sir.
Let us try to understand the solution. So this is the figure that I have. Now I need to prove that LHS is equal to RHS. So what do? I write AR square, AR square. I write AR square as AO square minus RO square minus OR square. Any doubt?
No, sir.
Then when I have to write BP square, I write BP square as OB square, OB square minus BP square. I write BP square as OB square minus OP square. OP square. This is what I've written here. And I write CQ square. I write CQ square. CQ is this line. So CQ square is, I join these two. So CQ square I can write as OC square minus OQ square. Any doubt, Mr. Rupert?
No, sir.
Now, once I have written this, then again I need to look at my right hand side and I need to understand what do I have and what do I want. So when I look at the right hand side, I understand that AO square, this is my AO square, minus OQ square, this is my OQ square, Now this square minus this square would be my AQ square. Any doubt?
No, sir.
When I look at OB square, OB square minus OP square, I will have BP square. This would be my OB square minus OR square. Sorry. So OB square minus OR square would be equal to RB square. This is my RB square. Any doubt?
No, sir.
And the last that I have is that O OC square minus OP square. This is my OC square. OC square minus OP square would be equal to PC square. Mr. Rudra, any doubt?
No, sir.
Basically, this will reduce to RB square plus AQ square plus A, sorry, RB square plus AQ square plus PC square. PC square. And this is equal to my right hand side. Any doubt?
No, sir.